Hi there. Today I'm going to go over our machine learning final project for which we chose to do image sentiment analysis. My name is Gavin Bosman. My other group member is Mekael Wasti. So our problem statement was we wanted to perform facial sentiment analysis over real-time live video. In the process of approaching this problem, we looked over various convolutional neural networks, such as ResNet 50, ResNet 152, as well as the VGG 13 and 19. And we wanted to compare and contrast these before we made our choice on the optimal model to use for deployment. So the data set that we used to train or further train these existing models is the EffectNet dataset. It's one of the largest facial recognition datasets created by researchers at Carnegie Mellon University, also with the University of Pittsburgh, and it contains over 400,000 images designed for training facial recognition as well as sentiment analysis tasks. So here's some example images from the EffectNet dataset. We can see each of these images and their associated label. So each image within EffectNet's dataset is manually labeled by a person with one of 8 potential facial expressions, which include neutral, happy, angry, sad, fear, surprise, disgust, and contempt. Each image is also given an associated valence, which is the positive or negative emotion associated with the expression, and also the arousal or the intensity of said expression. So here is just an overview of the pre-trained models that I briefly mentioned earlier. We chose to use the central ResNet 152 for our deployment, and I'll get into why in a little bit. So ResNet 50 is a 50-layer deep convolutional neural network. We utilized the pre-trained version, which was trained over the ImageNet dataset. And basically, this dataset contains over 1,000 classes of images. And this pre-trained version is already quite good and specialized at image classification tasks. ResNet 152 is the same basic architecture of ResNet 50, but it's just expanded to be 152 layers deep instead of 50. Obviously here with the extra 102 layers, it can be more computationally complex and it can take much longer to train, but generally you should have lower loss rates and also a higher level of validation accuracy. VGG19 is another popular convolutional neural network, which is kind of different than the previous two. It doesn't use any residual layers at all, and it follows kind of the standard convolution model that we had learned about in class, which follows the convolution, activation, and pooling and repeat for however many layers, using a fully connected layer at the end to form the classification. So we can see here just like visually with VGG on the left, we have essentially our standard. We form our convolution followed by our pooling layer, and you repeat this X amount of times, and obviously this will reduce the image dimensions throughout execution. And in order to perform classification, we use a fully connected layer followed by a softmax. We've seen all this before in our common convolutional models. And then on the right, we have the ResNet architecture with these arching arrows representing the residual layers of the model. And so we have one initial max pooling layer, and then all the way through each convolutional layer, there's no more pooling or activation until the very end, where we use an average pool instead of the fully connected layer, which reduces the computational complexity of the model. So during our training, here are the metrics that we used to specify the hyperparameters for the models. We generally stuck with a learning rate of 0.01 or 0.001 using a cross entropy loss. We use the stochastic gradient descent optimizer with a momentum scheduler, which we used step LR or reduce LR with the momentum set to 0.9. We varied the batch size from 32 to 64, and generally we've stuck to a training test split of 70%, 20%, 10%. And so you can see here, comparing the ResNet 50 and 152, the accuracy of the ResNet, the validation accuracy is 81%, while the ResNet 152 is 89.6%, which is almost 90%. You know, we have 9% better accuracy for the... So we're trading off some computation time and complexity to get much better results. We can see here as well, just visualizing over time how the model's trained. This one is ResNet 50, and we have ResNet 152, which we can see it gets much more accurate, much faster. And so to deploy this, we decided to make a web page using React. We had a dynamic JavaScript front end that communicated with our Python backend, where we had our pytorch model, and we had saved the state of our trained model, and we used that to communicate with the front end here. So now I'll just show you the demo of our website. Hi there, I am Gavin, and this is our final project demo of our live facial sentiment analyzer. So we decided to use the ResNet 152 model, the pre-trained model over the ImageNet dataset, and we further trained it using the EffectNet facial sentiment analysis dataset. And we used that trained model as a backend to our React app here, which gives you two options. You can either have the live video analysis, which I'll show now, and you can also upload individual images. So if we start with the live video analysis, you can see me here in the frame, and clearly it is saying I'm neutral because I'm holding a neutral face, and when I open my eyes, like, it's saying I'm surprised. You can also do clearly it thinks I'm happy. There's also, we have 8 possible emotions here, which I believe are happy, sad, anger, contempt, disgust, neutral. There's probably another one in there, but I'll try sad. There we go, it works too. And this is happening in real time with a slight delay. We're taking screenshots of the frame here and sending it to the backend with HTTP, and then we are evaluating that image with our trained model and sending that result to update the value on the screen here. So we can turn the camera off, and we can go here and upload a file. I have some examples here just for the case. So we press upload, and we can see that this happy old man here has been given a 94% accurate reading or prediction of happy. We can choose another example here. I'll try the sad one. These images are from the EffectNet dataset, by the way. And so we upload, and it's 100% sad. And so these labels are from the EffectNet. This is a sad face from the dataset. And yeah, so this is our live demo. Thank you for watching. And that is our final project. Thank you for watching.